See our screen?
Yes, now. Yeah, yeah. You can start.
Okay.
Okay, we are from Thailand, Department of Biomedical Engineering, and my name is Piarat.
My name is Nitipon of Nawaidipon. Today we are gonna present about advanced optical endoscope for cervical cancer screening, which is basically based on fluorescence technique.
So, this is the overall topic that we are going to present. First is problem statement, second, method, third is result, and the last is market. Let's talk about the problem first. The cervical cancer is the first most common cancer in women and is leading to cause of cancer death in women with 311,000 deaths from this disease in 2018. In Southeast Asia, the burden of cervical cancer is the moderately high. Per 100,000 of population, cervical cancer incidence is 23 of Indonesia, 21 for Myanmar, 15 for Philippines, and 18 for Thailand, 11 for Malaysia. Why is cause of death? Because we are lack of early detection. So the cancer is always diagnosed by a who expert look at the cell or tissue sample under the microscope. So today they use biopsy with a microscope, which have to use the it takes time to get the result, and they use endomicroscope, which is a bulky and expensive one. So we are going to develop the possible endomicroscope in the future.
Yeah. First, before we are going to talk about the detail in our project. Let's talk about what is optical fiber bundle first. The optical fiber bundle is typically it is the same as uh, optical fiber cable, but the difference is that the size of it is very small and they are dense together with a lot of small optical fiber cable to form the image transmission in optical system. So this is what we do. Our setup will mainly the same as the general microscope system. So the CCD is replaced from our eye and there are two lenses for focusing to the sample. Then we change the sample to be the fiber bundle that can transmit the image from the end of fiber bundle to our microscope system. And what we include more is the fluorescence that are going to apply in our microscope system. The first thing is the light source because we are going to work on reflective mode microscope system because we are going to observe in vivo inside the cervix of the woman. So we cannot, the only way that we are going to do is reflective mode only. And the next thing that we are going to need is the excitation filter and emission filter. Excitation filter is for select the wavelength for excite the appropriate fluorescence dye. And for the emission filter is to select appropriate wavelength that fluorescence molecule defect that it fluoresces back to our microscope system. So the dye, fluorescence dye that we use is FISI one. The FISI can illuminate the fluorescent dye to our microscope system. But the thing is that we have to find the appropriate peptide to bind with surface membrane of cervical cancer cell inside women. So in this case is P16 as the targeting peptide. The method to do this is to spread the conjugate peptide with fluorescence dye to the cervix of the woman and then wash it. The things that left is the fluorescence molecule that attached to the cell membrane of the cervix of the woman. Then when we inspect from our microscope system, we will see only the fluorescence molecule, means that we will see only the cancer cell inside the cervix of the human. So if it present on our system, means that they have cancer on their cervix. This is the result from now on that we got. Here at the end of the fiber bundle, if you put the skin lens, it will help us to focus on the exactly plane that we want. And this is the without skin lens. So we can see that the skin lens image is slightly darker than the normal one because the light is missing from the optical system, but the magnification is better than the one that doesn't put the skin lens.
So the competitive advantage first is reduce cost, portable, can be applied in our hospital, and time saver, which means that they don't have to cut the cancer cell to take a look at the microscope. And this is the market. So our project cost is $4,000 per unit, and the market size is over 1,400 hospitals in Thailand, including large, medium, small hospitals in Thailand. Thank you for your attention.
Yeah, thank you for this talk. Very interesting. The second talk about endoscopes from Thailand. So, but total different approach. So, questions from the jury, please.
So I see you're using peptide to imaging the cancer cells, right?
Yes, yes.
But I didn't see in your result. You show two images. Can you point out that where is the cancer cell and how does I just explain to me how does this image indicate the cancer cell?
Maybe from our result or from our expectation. Hello, can you hear me?
Yeah.
So the result is to from until now we just finished the imaging part, right? So we expect to see the cellular structure in micro scale of the image at the end of fiber bundle, right? But for the fluorescence dye, we are still working on it to develop the peptide that can fluoresce the cervical cancer cell.
So how are you going to apply your peptide? Are you going to inject your peptide to the specific location? And one more question about the image. So in the image, I can see the background with a lot of fiber bundles. Can you, in your future research, can you remove this background?
Let's first question first. The peptide will conjugate with fluorescence molecule and spray on the interest region. Yes, and can you explain more about the next question?
So in your image, in your result image, you show two images. So both of them has some background with a lot of small circles, right? Those circles indicates it is the fiber bundles. So can you try to get rid of all this background by showing a pure, more pure image of the cells?
Yes, we think we can by passing some image processing, we can eliminate those like bundle edge, right?
Yeah.
Yes, we can done it by using some image processing to eliminate those content.
Okay. Any other questions? Hello. Hi. If there is no more questions, I think we thanks for this Thailand team. And yeah, we have to have a rest.